Hello and welcome to the Data Engineering Podcast, the show about modern data management. Are you bogged down by having to manually manage data access controls, repeatedly move and copy data, and create audit reports to prove compliance? How much time could you save if those tasks were automated across your cloud platforms? Immuta is an automated data governance solution that enables safe and easy data analytics in the cloud. Their comprehensive data-level security, auditing, and de-identification features eliminate the need for time-consuming manual processes, and their focus on data and compliance team collaboration empowers you to deliver quick and valuable data analytics on the most sensitive data to unlock the full potential of your cloud data platforms. Learn how they streamline and accelerate manual processes to help you derive real results from your data at dataengineeringpodcast.com/immuta, that's IMMUTA, and get a 14-day free trial. And when you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode, that's LINODE, today and get a $60 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host is Tobias Macy, and today I'm interviewing Daniel Molnar about being a data janitor and how to cut through the hype to understand what to learn for the long run. So Daniel, can you start by introducing yourself?
Thank you for having me here. My name is Daniel. I'm an old bloke. I'm doing data for 10 plus years these days. Startups 20-ish, calling in from Berlin, Europe. Originally I'm coming from Hungary, but I live in Berlin for 7 years now, trying to help various startups and occasionally multinational corporations like Microsoft or Shopify here and there. Yeah, and I think that I got to realize that I'm actually a data janitor opposed to data engineer or a data scientist or data whatnot. Throughout all these shoveling stuff from A to B, kind of understanding that doing data, a lot of cases involves maintaining pipelines and making sure that you are invisible.
And do you remember how you first got involved in the area of data management?
10 years ago, when after a longest stint I spent in the e-learning industry, building products, I kind of realized that, this whole data hype is coming on us, and now you can do analysis, called at even at the time data science, on your laptop, and I was happy to chime back again to my Python and whatnot. But those are different days. I mean, you could still buy Google Analytics as an installable called Urchin. So things change pretty fast.
And so, as you mentioned, you've described yourself as being a data janitor as opposed to being a data engineer or a data scientist or machine learning engineer. I'm wondering if you can just start by sharing your thoughts on the overall state of the data management industry and the sort of ways that we tend to think about ourselves and describe ourselves and the segmentation of roles.
Being old maybe gives me a strange perspective, because I remember before Java. Java was the first thing that had $500 million as a marketing budget. And I keep that saying in my presentations and keynotes. I used to deliver at conferences. I'm not sure what will happen to conferences. The hype is just getting bigger and bigger, and anybody who's working with data, I think we live in wonderful times, because we have so much things to be using and so much computing power and so much understanding. But we should never forget about the incredible amount of marketing money that just showered on us, kind of trying to distort our reality perception, may I say. So on one hand, I'm happy because I think we can do things that, very few people could do 10, 20 years ago. I remember the moment when, let's name Redshift appeared on the market. And it's suddenly, wow, a data warehouse that doesn't cost you a car as a starter. So things are changing a lot, and things are getting cheaper and more robust and powerful. On the other hand, noise is super crazy big, and it's very hard to figure out, what's what. Some companies do allow you to make benchmarks. Some companies do not allow you to make benchmarks. And I think if you might actually got, the hacker news, front page bug, then it's even having this fear of missing out feeling every day, oh, something new happened.
And so, in the face of all of the changes and sort of constant introduction of new products and new ways of doing things, what is your overall strategy for being effective in the face of so much complexity and the conflicting requirements for data access and control and the shifting needs within an organization for what information to collect and how to use it and what to think about and what to focus on for being able to actually deliver something valuable?
I think I might sound like my own grandfather on this one. I think as people age, they get a bit more like conservative, and not necessarily because they think that, oh, everything was better in the good old past, but more like, I would even point out to Mr. Taleb, like Nassim Nicholas Taleb, who is not like a tech writer, but does write a lot about like, randomness and black swans and how the world works in his view. And even he points out to the fact that technology does not really age. If there's a technology that's with us for like 10 years or 20 years or even 40 years, it might make sense to look at why they stayed with us. So I would say that keep it simple and stupid is always like a good starter. Again, SQL, just like, for instance, is with us for like a long, long time. There might be a reason why we still use it. There might be a reason why I have not been taught SQL as a computer scientist when I was in school. Again, like talking about like how tech and business relates to each other. But anyway, it's here with us. It's going to stay. And just like if somebody, publishes a new NoSQL store on the front page of Hacker News, like let's wait how it will age and how it will perform.
Yeah, I think that's definitely a good heuristic for understanding what to look at and what to pay attention to is what is the staying power? How long are people talking about something? And there's definitely interesting things that come out of some of the new products, but it's also worth looking at what is it bringing that's actually new versus just a new marketing veneer to put a new spin on something that's been around for a few decades.
Yeah, and like, again, looking at back, what did we deliver? Or they like, if you can solve something in Bash, solve it in Bash. If you can solve something with SQL, solve it with SQL. If you can solve something with Make, let's use Make. Like, let's try to do things stupid first. And then if, it did hit the wall, then it might not be like premature optimization. So I'm also happy to be like the one in an organization who deletes the most code. Because again, I think if I'm putting on my maybe even an engineering hat, but more like a janitor hat. It's like we're not paid to write software or add more lines of code to the repository. We are paid to solve problems. And as we are humans and everybody's human, we are prone to error. It should be funny to take like the latest, Apache product, pull the repo and deploy something that has millions of lines of code and you don't know how it works. I'd rather be sleeping well. So I would say like it's better to have something stupid and simple in production that you actually understand, opposed to like, what's shiny and new and happy.
Yeah, one of the ways that I've seen this referred to is to choose boring technologies because they're the ones that have been around for a while. They're the ones that have been proven out in production contexts, and they're the ones that will let you actually sleep well at night, knowing that it's not going to crash because of some undiscovered bug because you're using technology that was introduced 6 months ago.
Absolutely. I'm a super big fan of Dan McKinley. I believe he coined this expression. And I even have like a sticker on my notebook coming from him saying, Avro is bad.
And so in terms of the overall challenges facing data engineers, what are some of the common difficulties that you see them contend with, whether it's technical or social and organizational? And what are some of the ways that you have used to overcome some of those challenges or to help others overcome them?
I would say, again, we have to know our role in this whole organizational setup. And I believe still that, like a data engineer, like a data janitor does its job well, invisible. We're kind of really making sure that everybody gets what they need. That also ends up having a bit of a problem here and there because nobody really, sees your contribution just when the whole thing fails. So it's pretty interesting how to balance this out, that, we have to show that the value you give is something that's super important. On the other hand, the nature of your job is not something that you can, necessarily present at a retro and have like clapping people standing out there. Hey, finally, production database is in sync with analytical database. Sometimes it's not that sexy. I think it's one of the major challenges. And it kind of falls back to that issue again that it also doesn't make sexy to become a data engineer necessarily. I think a data scientist got a lot of this love. Like everybody wants to be that because that's the sexy thing to do. If you become a data scientist and after 1 or 2 years, you realize that you might need also like other skills, how to actually get your data, how to actually put your model into production, then you might start to value like data engineers a bit more, I would say. That's like more like, I would say, the social or organizational part. On the technological side, I think what really makes practical perspective is that, I know if I look back in my previous jobs and I look back who I'm talking to these days, almost everybody seemed to be like doing some kind of a cloud migration or some kind of a hybrid setup approach. And a lot of cases, it's like production or like finance drives this change. In a lot of cases, data is just like kind of following and try to, stitch things here and there and make sure everything finds properly and well. I think that's something that can give you headaches in general. This type of backfilling, like data scientist, or like what to do, how to do, what's possible, what's not possible. Just because it runs on your computer and you manage to Dockerize it, it doesn't mean that we can serve this in production. And this is something where a lot of things come up. I mean, it's not hopeless. It's just a lot of efforts one has to put in to make sure that everybody is on the same page.
I think that that's definitely one of the things worth digging into is that, to your point earlier about the data engineering role being invisible when it's done well, similar to when you're working as a systems administrator or a platform engineer, unless something goes wrong, nobody knows that you exist. And your task is actually to try and automate yourself out of a job, which there are so many different things to do that it never actually comes to that point. But it's definitely difficult to raise awareness to the value that you're providing when you're doing things well, because, as you said, you're invisible until things break. And then digging into the point of the sort of different use cases of data, what are your thoughts on the position of the data engineer as far as being able to understand what are the actual needs of the data and what are the highest priority items to focus on when there are so many different people who are asking for information or trying to answer questions, and it's not possible for you to do all of them at once to be able to figure out what is the most impactful and most valuable thing that you can be doing?
I think the most impactful thing is communications. Like in my impression, data engineers are the ones who has to be the best at communication, like compared to front end, back end, maybe even like database architects, because I've seen these roles happening in kind of, dark corners, like, someone sits down and does the whole React thingy after like getting the tickets and just delivering. I think with the data engineering, it's really important to understand what is the business value we're trying to get, because I think nobody really has the whole picture. Let's say the business analyst, let's say data scientist and the data engineer, and they should be collaborating pretty closely to have a good grasp that what's feasible to deliver. And I have like war stories. I did shoot myself in the leg several times. That's why I try to preach this. That again, finally, I think the data engineer has to have like very, very great communication skills.
And in some ways, in order to be able to know what to ask and sort of what to focus on, it's difficult, particularly as a junior data engineer, if you don't have somebody more senior to help you along, to be able to push back on certain requests to say, I know that you're asking for this specific thing, but that's not actually what you need. What you need is for me to be able to focus on the foundational elements of this platform, because otherwise I might be able to get you that information, but I can't keep it up to date, or I can't ensure its reliability. And being able to prioritize within the constantly shifting needs of how the data wants to be able to access data and the increasing number of sources that are being dealt with. What are your pieces of advice or some of the ways that you have managed to level up yourself in terms of the organizational awareness and being able to identify what are the overall hierarchy of needs within the organization to know where to start focusing and what you can deliver in the long run versus just right now?
One is trying to be like super practical, and maybe it like really depends on like different cultures, but like standing in front of the mirror and trying to pronounce like no with like a steady voice. That's some exercise that is very worthy, I think. I always tell to my juniors that yes, it's totally fine to say no, Sometimes it's a bit rude, but I think it's a good starting point that you really have to understand the business rationale behind. And I think it's always fine to ask, what exactly do you want to achieve having this piece of data? Take like one more step further, which I call like the Friday 5 o'clock rule, because we've been there. Like Friday 5 o'clock, manager C-star runs into the room and like, yes, I want to have this piece of data now. I need it. Hopefully you're in a position to ask back and say like, fine, let's play out this thought experiment. I have this data for you now. What can you do about it? Can you make this product in production, like with your people, with the team? Can we change the marketing campaign? Like how it's going to roll out? Because again, if you're asking the simple question, otherwise like that, like, do you need this data like fast or do you need this data reliable? I might not even play out, the three options that you can have, just two of them. But again, it's very important to understand the context here. I might even point out the fact that if you look around in the job market, that's what I've seen, like as a hiring manager, a lot of cases that somehow there are some people who manage to get to like a senior level by themselves, but it's super hard to find junior data engineers. Like they just don't grow. Like here in Berlin, you shake a bush, 3 data scientists just pops up. But if you want to have someone who's kind of understanding basics, like, like SQL, Kimball, like good old stuff that might be true or not true or correct or not correct with our current set of technologies, but like kind of have an understanding of what are the questions I can ask, that's super hard.
And so in terms of the technical knowledge that you think is essential for data engineers, and to your point too about the difficulty of finding or training a junior data engineer, what are the sort of foundational elements of the knowledge and capabilities and experience that you think are necessary for someone to be able to work as a data engineer, either within a team or in particular in isolation within an organization?
I think the problem with this being a data engineer, like junior data engineer, is that you do not necessarily have to have like super deep knowledge of all things, but you have to have like a bit of a wider understanding of where data could come from, how we can handle it in a way that it doesn't hurt us, and how we can give it to the end user or like the business interested parties. And this covers a lot of things. So if you start with like data acquisition, you have to have some kind of understanding how logs look like in your backend, what type of databases you might have there, what kind of third-party APIs you have to talk to, basic concept of entities. There are these funny GitHub repos with titles of falsehoods programmers think about time, place, names. And I might even say like very special example, like time zones. Like who would have known that there's a time zone like 6.75 and why? But it's there in the database. A data engineer should be having a generic understanding of telemetry, like what you can do with third parties like Google Analytics, what's happening with ad blocking these days. A lot of open source tools are out there, more than what we need. If we can put these things somewhere, there should be most likely queues. Do you really have to have your own Kafka? Are you flying with Kinesis? Like a lot of questions and a lot of decision points. Then you get to the point of like ETL or ELT, whichever is more handy these days, how you orchestrate these things, how many people are trying to put things in your ETL, because tooling landscape might look different for you. What are the main like programming interfaces people are trying to talk to your data? Do they like more like happy with like SQL, decorative stuff, or do they want to do like programmatic stuff with Python, or even like you're into like functional, all different setups? Then you come to like data stores. I might even say like data warehousing, because these days storage and computation is not necessarily tied together. But most likely, your DevOps team or your generic IT gave you some kind of cloud to work with, or has some kind of, setup, which you might not be able to change. So you want to have like an understanding that, do you want to use like a software as a service thingy, or do you want to host your own solution? And then comes the BI tooling. Do you do like self-service data? If you do self-service data, who takes care of the data definitions, the KPI definitions? Should they be like programmatic? If you want to serve like any kind of data product, be just like anything more complicated than a dashboard, like how do you deploy it in your own setup? Can you deploy the stuff your data scientists produce you, even in R, Python? Then you have to have a bit of understanding of CDCI, some kind of testing, and how to put all these matryoshkas inside of each other, like Docker and Kubernetes, VMs, containers, just a bit at least. And yeah, if you want to serve like machine learning in production, that's also something. How do you pre-compute stuff? How do you cache things? How is your feature factories working? And we're not even talking about like the actual product that your data scientist might want to deliver, even just like, I know, a recommendation engine or like something related to search. So you should be at least a grasp of all these things, I think. So you're really this kind of connector or like glue between different stakeholders, different type of engineers. And this might be complicated.
Yeah, I think that one of the defining characteristics of data engineers, similarly to people who are working in DevOps and platform engineering, is the capacity for systems thinking and being able to understand what are all of the components of this overarching system that I'm trying to work with, how do they interconnect, what are the cases where they don't work well together, and then being able to understand understand holistically how it's all going to play together and what are the different pieces that might potentially fall apart in that overall lattice.
Yep. And I think in this one, being trigger happy as a data engineer is like always like a bad choice, because it might be like super unsexy to have files transferred between microservices as a separation of concerns. But maybe we shouldn't start with like a real-time system where, you know, if you lose like one record, you have to roll back everything. So again, I have an example for that. Like I think one of my best DevOps engineer ever in my life was a guy who used to be like an auto mechanic. He didn't want to program. He wanted to understand the things and solve them with the least amount of friction.
Yeah, that's definitely a useful background, because as with software systems, there's the mechanical systems that have to be able to interact and play well with each other. And there's the similar paradigm of common interfaces between components so that you can swap things out and upgrade it in isolation without having to worry about taking down the whole system, as long as the contracts between the different elements is maintained.
Yep. I agree totally. And I think that's also something very important that, again, I don't know, if you're like a front-end engineer and you're dealing with your React app, maybe we might want to interact with you when we talk about like telemetry and stuff. But you're kind of isolated. You might be like, that's your own turf. And if you can call in decisions here and there. With data engineering, like it all boils down to you. So if there's like a leaking pipe up there somewhere, you will see it in some time. So you're much more exposed to all the components of like the big system, even if like everybody's trying to make their job the best they can in like all these separate parts. You are relying on all of them. You are dependent on all of them in some ways.
In your experience of working as a data engineer and with other data engineers, what are some of the common gaps in knowledge or experience that you've seen people contend with, and some of the ways that they've tried to remedy that?
I would say that going back to the past and going back to the roots, I wouldn't say that, you know, the big Kimball book is like a welcoming thing. Nobody wants to read that 500-pager, like business-oriented whatnot, just like because they're going to have fun with it. But again, it might give you some ideas that how did we solve these data-related problems when we had like much, much slower and limitedly resources. If your ETL is technically like a directed acyclic graph, like there are things that depend on each other, and I know they should be retrying, and you should know what's the data quality, what failed, what not. Our open source ETL setups that we developed started as a joke, like, you know, can we make it with Make? Yes, we could. Like, let's try again to look back things that are there for like 50 years. Let's not try to reinvent the wheel if it's possible. And again, one practical thing is like lines of code. We were at Microsoft with my team. We managed to open source our solutions in a way that we figured that anything that is less than 5,000 lines is a code sample for Microsoft. And we liked this kind of limitation because we could ship fully working, cloud agnostic, event tracking solutions, even with test suite and whatnot, under 5,000 lines. And I think that it's kind of the feeling when I'm interviewing like junior data engineers and I ask them like a super simple question. We have some data in the App Store and we want to have that data in our data warehouse. What do you do? And unfortunately, I would say like 7 out of 10 cases, the answer comes like, I start up a Spark cluster. And I say like, thank you. No, thank you. Like, you don't need to start up a Spark cluster to talk to a third-party API. Maybe you need it, but most likely not. I mean, I'm a big fan of the band called Depeche Mode, and I just recently realized that their name is actually meaning that fashion of the day. And this is my problem. I think this is like the biggest gap in a lot of cases, that everybody is like super up to date with the fashion of the day. They cannot stitch a little back dress. So I think if you're like an engineer, even if you leave this fashion industry we are in, you should be able to deliver that piece of clothing that goes well in every occasion. You can start experimenting with different, colors and textures.
And so in order to help to bring up a new generation of data engineers, you recently started down the path of building a boot camp for helping to train them. I'm wondering if you can talk through some of your motivation for embarking on that journey, and if you can maybe discuss a bit about your particular approach to helping to bring people into this ecosystem and into this problem domain.
The greedy part from my side is that I had so hard times to find like a junior data engineer. I don't see them like coming from anywhere. And I see that there's like a lot of need for them. If I call myself like a data janitor, then they're like data janitor helpers. You don't necessarily have to be able to, quote the Martin Klapman book on designing data applications, on how to do you don't need to build on a zookeeper, okay? But you should be able to debug a complicated SQL query. You should be able to understand what the explain tells to you and how it's going on. On the not so greedy side, I see, again, a need for these people. Like, it seems like that this COVID situation showed us that some jobs are a bit more resilient than others. I'm seeing there's just a recent tweet that, the open deep learning positions just plummeted recently. I'm hearing about full data science teams getting chopped by the finance team when they look at them and say this is the cost and this is the uplift. Thank you, but no thank you. It might be the case that data engineering is not a sexy thing, but you need plumbing. You will need plumbing, whatever you do. You have to have these systems humming. And again, I think that DevOps and data engineering are the two most interesting fields these days. I think DevOps needs from you much, much more deeper understanding of holistic system view. And I can even imagine that if you're a junior data engineer and you like this part of the game, that you have to understand these interconnected things. You might even want to be a DevOps person later. Kind of the same way that, if you look around and say see these ads for junior DevOps people. For me, it's a bit of a contradiction in terms. You have to spend some time in industry to understand and feel the pain that what DevOps means. So I don't think that also kind of exists.
Definitely a good point, too, about the fact that junior data engineers is not really something that people aspire to or something that there's really a good pipeline for, similar to DevOps engineers, where because of the breadth of knowledge that's necessary to really be effective, a lot of times people will come in from adjacent roles where they maybe started as a software engineer and then they decide to start working more in the data space, and they aggregate and accrue the necessary knowledge and experience to eventually move fully into the data engineering space. And at that point, they're more of a senior level. And so I think it's definitely helpful to have a way for people to jumpstart their career in data engineering and go straight into being effective at the entry level with the breadth of knowledge that they require, versus just having to organically discover all of these different elements and then figure out later what the gaps in their knowledge are and try to fill them either by themselves or by taking individual classes or reading specific books to be able to understand what are the pieces that they don't fully grasp.
And from a very pragmatic, money-oriented perspective, what I kind of see in the market is that, we had this great influx of, PhDs who went to a data science boot camp, paid some monies. They're super smart. They learned data science. They got a job that paid well and better than what they could earn as a PhD. They learned about industry first, proper job, see how it's working, hearing about all this funny stuff like version control, tests and things. And after 1 or 2 years, again, I believe that some of them might have this feeling that I can be much more productive if I know a bit more of a data engineering, either on the data acquisition side or putting my thing in production. I also had an experience that if you're a business analyst you might not thinking that you need like super complicated models. You don't want to be a data scientist. Still, you want to acquire data. Still, you want to ship your data products. I mean, most of the data products I've seen in my life in production were not like super complicated models. It's something that serves the company from the inside, from outside. It doesn't have to have like deep learning, but it has to be like put in production. It has to talk to database properly, etc., etc. And even in my previous like job, I was super happy to retrain a front-end engineer to become a data engineer. So I would say like that much into data, but he understood like the engineering practice that, again, what version control means, how do you interact with people, how do you talk about these things with them. I think it has to have some kind of ingrained like motivation. So like you feel the need for that. And then you can add on top of that. I mean, it's not rocket surgery. It's again, I think more likely that what are the things that you really need to focus on? And what are the things that say like, yeah, you might need that tool, but if you need that tool, you really go, and Udemy, Udacity, spend some bucks and learn about the tool. But it's just like a tool. It's not like perspective. It's not like an understanding of what is the problem you're trying to solve.
Yeah, there's a really good presentation from Jez Humble on the DevOps side of things talking about don't hire DevOps engineers from external sources, start growing them internally, because it's easier to start with somebody who has a base level of capability within engineering and then help them to acquire the necessary skills to be more broadly effective. And I think the same holds true with data engineering.
Absolutely. I agree with you because, again, it's some kind of a T-shaped understanding of your systems. If somebody is with you for like 1, 2, 3 years, they have a much better head start to become an effective data engineer, even then opposed to someone who just comes in and knows Kafka and whatnot. But again, a lot of nitty-gritty small details of how your company actually works that helps.
For people who are applying to your data engineering academy, what are some of the common reasons that they have for wanting to become versed in data engineering and move into this particular role?
I think we have a pretty nice feedback in terms of like, we see this justified. There was a fellow who's working as a research engineer, like a research, like in a scientific setup. He looked at our curriculum and said, yep, this is what I have to fill in. Like exactly these things. Like I have to have like a solid practical understanding of data management, day-to-day operations. I know Apache projects come and go. Again, you can learn about them. I would say that where we try to save you time is saying no, don't go down that route. Then we also try to explain like why we think it's not something that really belongs to like the core values of the thing. It might be like just a manifestation for this given time. But again, if you understand, how MPP data warehouses work, you might want to skip Hadoop.
And for people who are applying, what are some of the baseline capabilities that you expect or anticipate for your target audience? And what level of proficiency or capability do you aim for when they've completed your program?
Prerequisites are really centered around SQL as a declarative language, kind of understanding how that works. And also, I really like Python because Python is not the best for anything, but it's good enough for most of the things. And it serves as kind of a lingua franca between different teams. Like even if you don't program in Python, you can kind of understand what's happening. So some kind of background also in like procedural approaches. And also, if you've spent 1 or 2 years at the workplace, anything, and you've seen your company's or your team's specifics on how to handle tickets, how to handle version control, what is your branching strategy, so kind of have a basic understanding of the contemporary software development setup, even if you're not necessarily doing that, like as a data scientist, maybe. This kind of context or awareness, I think, is really needed. And I think if you do this with us, we hope that you can walk away with practical knowledge, practical examples of what can you deliver. And I mean, it's super hard to turn somebody to anybody else in like 3 months' time. But I believe that giving you the self-confidence that I can do this is the most important thing. Because even if you're getting faced with the latest, we use Flink and I haven't seen Flink before, great. You might be able to understand where it's on the landscape, what you can do about it, and most likely you can fake it with Unix tools first. So that's always my promise, which I try to keep, is that you might not be able to deliver like the sexiest application or solution for a problem, but you can deliver one. And that's a good starting point. I think that's the most important thing. What is in production and what is not in production. If you ask me to ship machine learning product, what I would do is I would try to ship a simple Python Flask application according to your DevOps setup. I don't care where I should put it. That will roll your dice. And it's bad, what it gives you, but it's in production. We can improve it. Instead of trying to figure out what's the best way to cache or what. No. Let's put it there, and then we have something that's working.
I think that general approach of don't let the perfect be the enemy of the good is a good way to approach it. And it's definitely easy to be stuck in the analysis cycle of what are all of the different potential problems that I'm going to run into and how am I going to engineer around them before you actually even experience any of those cases. And that's where the sort of guiding principle of you ain't going to need it comes in, where just solve the problem that you have today, but do also make sure that the way that you're solving it is extensible so that you can solve those other problems in the future, but don't try to solve everything all at once because then you're never actually going to ship anything.
I totally agree with you. And I think that's also part of being the data janitor, that it's kind of okay to ship something simple and half-length, but you will be the one who has to keep that thing alive. So you have some kind of interest in making that thing happen, really.
And for people who are applying to your academy, what are some of the cases where you think they wouldn't be a good fit and they might be better served by doing some self-guided learning or a different type of educational approach?
I believe, again, that if you need like an understanding of a tool, or if you have to do some very specific cloud-related setup, there are like super resources out there, even produced by the companies that actually like make these products available. What you will miss is kind of the camaraderie of this whole thing. So we had like a trial run in the spring for like 1 week, and we started out the school just when the whole COVID thing hit Europe. We were like pretty big believers, and still are pretty big believers in face-to-face and being in the same room and sweating in the same room with these people, doing pair programming, rubber ducking, whatnot. And this was the main feedback we got from our pretty mixed people who took part of this 1 week course. It's like, think about it. We had like product managers, we had data scientists, we had like, I would say, plain vanilla engineers. From Monday morning to Friday evening, we managed to get from nothing to a shipped, Dockerized data product that they can push the button and it works. It was successful, they liked it, but everybody came back with the feedback that this should happen in person. But somehow, I think the format of the bootcamp that, we actually think about maybe we should start like a quarantine bootcamp that you cannot leave. I mean, you get there and you just focus on pushing through all these challenges and boundaries with your team members. And we're happy to give this feedback even to people who apply to us, that you better spend $30 or $100 or like $400 at this course and that course and other course, because you'll solve your problem better. You will need different self-motivation, a different way of how do you push yourself through this whole setup. I mean, if you have to solve that specific problem, we will not be able to help you. If you want to learn Kafka, there are super resources out there. Go learn it. We can talk to you about queues.
Going back to the broader level of your experience working in industry and working with other engineers, and if you're in the context of hiring somebody for a data engineering position, what are the core capabilities that you look for, and what have you found to be useful methods for being able to assess their overall competence and fit for the particular role?
I think I mentioned just recently this one specific example, like, I asked someone to get like data from a third-party API, and they start to enlist their favorite tool, which is typically Spark these days. I think I know that we're not like a good fit in this one. My idea of feedback, such a question or such a request would be like, okay, what's the data volume we're talking about? How often this changes? What do we know about the schema? What are the systems you already have? Again, I think we try not to add complexity if it's not necessary. We have enough complexity coming from the company and the organization all over the place. So if you can remove a component, then we rather do it. So this kind of reductive approach, I think, is very interesting. And again, kind of the car mechanic perspective. Just because I have a hammer, not everything is a nail. I have to figure whether if I have to pull my hammer at all to solve this problem. So I think, again, communication, understanding of context, problem solving, not coding skills. I mean, I'm super happy if you can deliver coding closure. I know you're super smart. Actually, I think one of the best microservices we had ever in production was written in Clojure. But, if you wanted to change something, it was like medical consilium. Like everybody got together, like which bracket should we remove type of thingy. So I'd rather have a person who, again, solves everything in Python, but can talk about it, why she's doing it, how she's doing it, because most likely this will happen talking to the other part of the organization, than to have someone who, is like a functional language guru and can deliver the best performing whatnot.
In terms of your overall perspective on the data management and data engineering space, what are some of the current and emerging trends that you are worried by? And what are the ones that you are personally keeping an eye on and that you're happy and excited about?
What is worrying me a bit is this repeating cycle of what typically I see happening with Apache solutions or products is that, there is like open source solution that should be working for everybody and it should solve like a problem, no big deal. And then suddenly there emerges like an accompanying company that gives you like consulting services that gets funded by VCs with like hundreds of millions of dollars. While we know that consulting is not something that, you can scale, like either you're building a product, but then this whole open source thing is just like a marketing ploy. So it's happening with everything, even with a thing like Airflow. If you want to put Airflow in a container, you'd better pay for it because, it's super hard to do it on your own. And I found this worrisome. I don't think that there's like, and on the other hand, what I'm a bit worried about, again, I mentioned that I see a lot of like teams and companies are migrating from Cloud A to Cloud B. We're trying to do some kind of a hybrid setup. I never heard back anything good from that up until now. I mean, you can do it if you have to. But the big providers are working hard so that the solutions are not exactly comparable, not even in pricing. If you have like a properly working setup in one cloud, good luck to find all the corresponding components in the other cloud. This is, again, it's good news for data engineers because we're going to have a job because this things has to be handled. But, we could do better, I think. You asked me about also like what I'm keeping an eye on. I see that SQL is coming back. I'm happy about that. It was always like this kind of bastard child of thingy. And I think that was the reason why I has not been taught SQL in computer science when I was learning, because it was like the business thing, we don't care about that. That's not a language. That's like something that business people do. And I'm seeing that bouncing back properly. Again, what I see is that we have tremendous amount of computing power and crazy good solutions that we can use for even like peanuts. In this one, I'm like, we're so much empowered from a technological perspective, wherever I go, like in every cloud provider or like every, I just mentioned all these Apache products or solutions, I can find something useful and great. So this is out there. It's just like, again, it's another job to be able to keep up with all the news and whatnots.
And as you continue to iterate on your work at the Pipeline Data Engineering Academy and work through the initial cohorts and start to plan for successive ones, what are your overall goals for that program and some of your plans and some of your personal aspirations for the work that you're doing?
I would like to share the pain and the shortcuts. So I think what our personal aspirations are that we believe that we can help people to get a decent job, not making a lot of mistakes that we did, because nobody told us that this is not something that you should do. The heart that it has to feel it to believe it. So like most likely some of these things has to happen to you, but I would be super happy if data engineering is becoming more of a respected thing, again, at least as a plumber. If we can help to fill the need for junior data engineers, then I could tap on my shoulder.
Are there any other aspects of your experience working as a data janitor and building the Pipeline Data Engineering Academy, or your overall perspective on the data engineering ecosystem that we didn't discuss that you'd like to cover before we close out the show?
I think to keep on talking for a long time, but it might be like a rounded closing now, because we can get into a lot of details on how we actually, build up these teams and how you figure how can you transform, and what is the ratio of skills and the amount of people, like how many data scientists and how many data engineers, and how they can work together. So I think there's lots more to the organizational perspective, and it's very different in different sizes of companies, different maturity of your data culture. But I think that we need more junior data engineers, and we'll try to do our best.
Well, I'm definitely happy to have you back on to dig deeper into some of those other topics. But for now, for anybody who's interested in getting in touch with you and following along with the work that you're doing, I'll have you add your preferred contact information to the show notes. As a final question, I would like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
We should have some kind of common understanding of metadata and data quality handling. I mean, there are some very great examples how people try to address this. But again, it's something that strikes back from the past, good old Kimball data warehousing days. It's not as super sexy, but more and more people start to realize that if you have all these real-time queues here and there and everything is just up in the air, it's better to know how much you can trust one piece of information and how you cannot, because we cannot achieve perfection.
Thank you very much for taking the time today to join me and discuss your experiences working in the space and your perspective on how we should all be thinking about and approaching it. It's definitely a very challenging ecosystem that we find ourselves in, and one that we're all trying to find our own way through. So I appreciate some of your perspective and guidance to the up-and-comers in the data engineering space. So thank you for all of your time and effort on that, and I hope you enjoy the rest of your day.
Thank you for having me. Keep up the good work. Git push, origin master.
Thank you for listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.